Hey guys, in this video I'm going to show you how to wire up an automotive relay, your typical cube style relay. Sometimes they'll come with this wiring harness that you can plug into the base of the relay. Sometimes you can, or they won't, and you can just put spade terminals, the crimp terminals on here and wire it up yourself. So if you're not familiar with a relay, basically all a relay is a switching device that allows you to separate voltage. If you have a circuit that doesn't have a lot of current, you can use that to switch another circuit that has the current you need to supply to a device. It's a way to not have to have a large current supply running, let's say, into your cabin to a switch and then back out to a light or some sort of accessory that'll draw a larger amount of amperage. So this relay is rated to 20 amps. It's a 12 volt relay. You can see on the base of the relay we have all of our terminals here, which I'll show you how they're labeled here in a second. And then we have a wiring diagram. You can see there, it probably won't focus. There you go, we have a wiring diagram for the relay. So in a typical relay circuit, you'll have a few different things. Number one, you will have a coil circuit, which in an electrical drawing sometimes will look like this. You'll have the positive side of the coil and the negative side of the coil. The positive side will be hooked to your switch. You'll run from your voltage source here, and you'll run into your switch, and then when your switch makes, it provides power to the coil, and your negative side of the coil will go to a 0 volt reference or ground. And this will obviously be your 12 volt. So that's the coil circuit of a relay. And then you'll also have what they call contacts, which look like this on a drawing, or sometimes they look like this. And what that is the actual circuit that you're going to be controlling with the coil. So if your coil switches the circuit, this is the circuit that it will switch. And there's two different types of contacts here. You'll see a normally open, which is what this is, and then you'll see a normally closed. And the difference is the normally open circuit or contact set will not be connected in its normal state. And its normal state meaning that there's no forces being applied to the relay. So in its normal state, that circuit will be open or disconnected. A normally closed contact circuit will be connected in its normal state. So to explain that simply, when you apply power to the coil, a normally open circuit will make and send power through. And when you apply power to the coil, a normally closed circuit will actually break and stop voltage from going through. So that's your typical circuits that you'll see on a relay. Another way that they're shown is you'll see on an automotive relay, you'll see a device that looks like this. That's your coil circuit. And then you'll also see something that looks similar to this. And then you'll have, going to one side will be your normally closed circuit, the side that it is touching, and the side that it's not touching will be your normally open circuit. And when it switches, imagine this being an actual switch, your voltage source will come from here and it will connect over. So when it's energized, it'll move over that way and make a connection with the normally open, and when it's de-energized, it'll move back over to the normally closed. So on a standard automotive relay, like this one here, you'll see there are 5 terminals. You'll have 2 on the top. You'll have 1 below. You'll have 1 to the left and 1 to the right. And that's a traditional automotive relay. So you'll have 1 labeled 30, which will be this one down here. Then you'll have 85. You'll have 87. And you'll have 87A and 86. And if you look at your drawing of your circuit diagram on the relay, you can piece this together and see that this is the coil, and coming off of the coil you'll see 86, 85 off the top of the coil, and then beside the coil you'll actually see 30 that will go up and connect via normally closed circuit to 87A, and then you'll see the normally open circuit of 87. So this is your typical circuit diagram that you'll see on the side of an automotive relay, and then that is your actual pin configuration on the underside of the relay, just like that. So what this tells you is if you want to figure out where the coil is, you're going to be on pins 85 and 86. And if you want to figure out where your voltage is, you'll be on pins 30, 87A, and 87, depending on what type of circuit you want to use. So now that we understand this, let's apply that to a typical circuit in which you'll use an automotive relay. Let's say you have a set of lights in your car. You have light and another light, and they're auxiliary lights, and you want to power them, but you don't want to hook them directly to your battery because then they'll always be on, and you don't want to run the battery voltage into your car and then back out to the lights because it's a very heavy current draw, and you don't want to run that heavy of gauge of wire in and out of your car. What you can do, you can pull off of, let's say, your headlight switch that's existing. We'll call that your headlight switch that's existing. And then this will be your voltage supply for your battery. So what we'll do here is we'll use the headlight switch to actually switch the auxiliary lights, and we'll use the battery supply to power the auxiliary lights. So from your headlight switch, you'll find the hot wire, or the wire that sends voltage when the switch is on, and you'll actually wire that to the coil of your relay. The other side of the coil will go to a negative or 0 volt, or some people call it a ground reference. And if we look at the terminations on the bottom of the relay, you'll see that 86 is the pin that you will hook to from your voltage source of your headlight switch, and 85 is your ground reference for your coil. So what that means is when you turn on your headlight switch, it applies power to the coil of the relay, and because you have a ground reference on the other side, that relay will actually click or engage, the coil will draw in and make the circuit inside of the relay. So now that controls the actual relay. Now let's get the voltage to the auxiliary lights. So on your auxiliary lights, you'll obviously have a positive wire and a negative wire, or a red and a black wire. Your negative wire will simply go to a ground. You can run it straight out, bolt it to a chassis ground or some sort of metal on your truck or car that you'll want to have cleaned and prepped so that it'll make a good connection. Obviously your battery will already be connected to ground, so coming out of your battery it will already be connected to the ground, and that's where your lights will be able to make a connection back to the battery if you connect them to a chassis ground or some metal point on your vehicle. Now your positive, I'm going to show you two different ways of wiring these and show you the reactions of what happens when you wire them the different ways. The first way is via the normally open circuit, which would be pin 30 and pin 87. You can see there pin 30 and pin 87 on our relay. So through the normally open circuit, we'll take our positive voltage from the headlights and will come out to the relay, and we'll connect that to pin 30. Pin 30 is our voltage source. From that, we'll connect to, on the other side of the relay, to pin 87. And then from 87, we'll branch to the individual positive terminals of the lights. And with this type of circuit here, and we'll show this being normally open, meaning the switch is not in contact with the circuit. When the coil energizes here, when you flip your headlight switch, the coil energizes and draws this normally open circuit in and makes a connection between 30 and 87, sending your battery voltage directly to your lights, so you have enough current to supply the demand that the lights have. Now and what that does is when the switch is on, the lights are on. If you want it to be opposite, we would wire the normally closed circuit. We would still bring the voltage into pin 30, but instead of pin 87, we would actually run it to pin 87A. And you can see how it's normally closed. And then 87A would go out to your light source. What this means is when your coil is not energized, meaning your headlight switch is not on, your headlights actually will be on because they have a closed circuit to the battery. When you energize the coil by turning your headlight switch on, it actually breaks the connection between 30 and 87A, which will turn your headlights off. So that's the difference between normally open and normally closed on your relay circuitry. So there you have it. I hope that helped you understand a little bit about how these 12-volt automotive relays work. Again, you can get the pigtails with these where they plug up and you already have the wiring, and you can see the two outside wires here are thinner gauge because they are just to control the coil of the relay, which doesn't take a lot of current to operate. However, it allows power to cycle between these three wires here, which you can see are a much larger gauge to support. I think these are 12 gauge wires, which will support 20 amps on this automotive circuit.